It was 1949. In the world of science, Albert Einstein had already become famous. And what do all celebrities have? Well, fans, of course. An English engineer was brave enough to write to the great Albert Einstein himself. Unfortunately, historians didn't find the original letter, but they recently discovered Einstein's reply. It is short, one page only, but the content is fascinating. He wrote of animals that possess super senses. Sounds out of this world, but it actually isn't. More than 70 years ago, Einstein wrote down the following. It is thinkable that the investigation of the behavior of migratory birds and carrier pigeons might someday lead to the understanding of some physical process that is not yet known. Back then, this was just a hunch. Biology and physics were just beginning to explain the behavior of animals. Take, for example, bats' echolocation. An American professor of zoology was the first to describe how bats navigate. In English, there is a phrase, as blind as a bat. And in some languages, the name for the species literally translates as blind mouse. This is because bats don't have sharp and colorful vision like humans do. Now, this doesn't mean they need to visit an optometrist. Bats can see pretty well in pitch-black conditions, but they don't use eyesight to navigate. Bats use echolocation. To understand what it's like, tell me, have you ever been inside a cave and yelled out your name? Did you notice how the walls responded to you? This is an echo. The loud sound you made simply reflected off the hard surfaces around you. This happens in any space with solid walls, such as a canyon, a mountain range, or a well. Sounds can't bounce off soft surfaces. Yell your name in a room full of pillows, and you won't get a reply. Bats use this echo to get around. The animal produces a high-frequency sound through its mouth or nose. Then they wait for the echo to come back, and voila! They have an accurate 3D image of the world around them. Bats' echolocation is so sophisticated that it can detect an object the width of a human hair. Now, that's impressive. Scientists estimate that 70% of bat species have the ability to echolocate. So bats are not blind after all. But we didn't know all this until the 1940s. That's when the American scientists coined the term echolocation. This was a major breakthrough in biology at the time. Einstein probably knew about it, so it served as a clue for him. Another hint was radar technology. You know how in airports they have that round screen with the tiny dots that represent airplanes' positions? Yes, that's a radar. And it works using the same principle bats use to orient themselves. The development of radar as we know it today began only in the 1930s. At the time he wrote the letter, Einstein couldn't have known how this technology would change the world. The radar approach for civilian aircraft appeared in 1952, 3 years before Albert Einstein passed away. But his letter also mentions bees. Einstein wrote that a new kind of sensory perception would be revealed through the behavior of bees. What did he mean by this? What is the extraordinary ability that bees have? Like bats, they're champions of navigation, but they don't use echolocation. Bees possess the ability to detect the Earth's magnetic field. It's generated in our planet's interior and it extends into space. You know that image of Earth with circular lines around it? That's it. The magnetic field shields us from the sun's dangerous radiation. Without it, there would be no life on our blue planet. And there's another perk to Earth's magnetic field: navigation. Since the 12th century, Europeans have been using compasses to get around. That's how we discovered much of our planet. These devices contained a magnetized needle that rotates in the direction of the magnetic north. Even today, when you open Google Maps, you can still see the symbol of this needle. Click on it, and the map rotates north. But a bee doesn't have a smartphone or a compass, so how do they know which way is north? Researchers believe that these animals have tiny receptors inside their abdomens. They consist of iron granulates that act as mini compasses. Just imagine that. Bees are born with navigational devices inside their bodies. And all humans have to download a map on their phones. Bees also use the sun and light to navigate. They can travel up to 5 miles from the hive when looking for food, and they always find their way back. Bees are the ultimate flight planners. And they're not the only ones. Dogs are also excellent pathfinders. Take, for example, Pablo. He was a 2-year-old hunting terrier. One day, Pablo went camping with his owners in the French Alps. During a stop, the canine went missing. At this point, a human would go to the nearest house to get help. But not Pablo. The lively mutt immediately started walking home. In just a couple of days, he returned to his owners. His home was more than 200 miles away to the south from the spot he got lost in. That's 3 days of nonstop walking for a human being. How did Pablo pull off this stunt? The same way bees do, the Earth's magnetic field. Before such cases, scientists believed that dogs only use their sense of smell to navigate. Then, experiments showed that dogs don't retrace their steps. They use a different path to find their home. Since they obviously didn't use GPS, the only other possibility was the Earth's magnetic field. If you think that such animal behavior is fishy, that's because it is, quite literally. Fish are among the most skilled navigators in the animal kingdom. Salmon are the best example. They hatch in freshwater rivers and start a long journey to the North Atlantic Ocean. They often cover a stretch longer than the I-80 interstate freeway. That's the driving distance from New Jersey to California. The journey can last years, but it's the end that is the most impressive part. They turn back and head the same way to breed again. There is a compass of sorts in the salmon's nose. Scientists found small deposits of a magnetic mineral in the fish's sinuses. In fact, salmon's sense of smell is 1,000 times more sensitive than a dog's. Finally, we have migratory birds Einstein mentioned in his letter. In Asia, there are geese that cover distances of over 3,000 miles during the migration season. Scientists agree that their sense of smell can't get them that far. Biologists have tried to explain birds' excellent navigation skills in various ways. Some believe they use the sun and moon to find their way. Others claim birds use landmarks to orient themselves. And then there is the explanation that involves the Earth's magnetic field. Researchers noticed a small spot on the beaks of pigeons. It contains a magnetic rock they believe helps the animals navigate. Bees, dogs, fish, and birds. Did you also spot a pattern emerging? That's because there is definitely a link between all these species when it comes to navigation. But after decades of research, science hasn't been able to fully understand how animals sense the Earth's magnetic field. The mystery lives on, and it only gets deeper. You've probably heard that cats can sense an earthquake. This happened in a cat cafe in Osaka in 2018. Just 10 seconds before the ground started to shake violently, the felines there seemed agitated, as if something had scared them. Did they feel the tremors deep underneath the surface of the Earth? One explanation is that they can sense the planet's magnetic field. This means they can feel minor tremors that humans cannot register until it's too late. At the end of his short letter, Einstein mentioned that further research was needed to explain this strange phenomenon. The famous German was a theoretical physicist. Biology wasn't his primary field of interest. And to explain how animals navigated, all sorts of scientists needed to get involved. Einstein didn't want to discuss something he wasn't an expert on.